Hello all, welcome to the Security Tube Linux Assembly Expert course and certification. Now in this video we will begin module 2, which is Introduction to Shell Coding, and we will look at the basics of shell coding. So what is shell code? Now very simply put, shell code is machine code with a specific purpose. Now traditionally, shell code meant either spawning a local shell or spawning a remote shell bound to a port which the attacker can access. Now today, shell code is pretty much loosely used for any payload which ships with an exploit, which could include doing things like creating an account, uploading and executing files, and a bunch of other possibilities. Now the most important thing for you to realize is that shell code can be executed by the CPU directly. There is no further assembling, linking, compilation, interpretation, or anything required. And this is what makes it so very powerful. So how is shellcode delivered? Now, it can be delivered in either of two ways. One is as part of an exploit. Now, this is where the size of the shellcode is very, very important. Smaller, the better, simply because almost every exploit has a constraint on the payload size it can deliver. Now, another important aspect of shellcode delivered part of an exploit is that there could be certain characters which may hinder with the exploitation itself, and these are called bad characters. So one needs to ensure using encoding or other techniques that the shellcode being used with the exploit does not contain any bad characters. 0x00 is the most common one simply because it marks end of string, and most exploits do not allow using of this specific code, or rather this specific byte value. The other option is to deliver shellcode in the form of a self-contained executable, which can either run as a separate thread or even replace the current executable's functionality entirely, right? Here, typically the size of the shellcode and even bad characters aren't much of a concern. So resources, you can visit Shellstorm, ExploitDB, and Project Shellcode for good resources on shellcoding. Now, before we begin our journey into creating shellcode, the question arises, how do we test if our shellcode is working properly? And this is where we need to use a skeleton program which will allow us to execute the shellcode and test it within our own safe environment. Now, the code snippet which you see in here is the most commonly used skeleton code for shellcode testing. So let's get right into it and test a piece of shellcode with it. So here is the skeleton program, and I've pasted some shellcode in here. This shellcode is actually taken from Shellstorm, and this is the URL /shellcode/file/shellcode-806.php. And really all this does is it executes bin.sh, as you can clearly see. Do not worry about the exact assembly. We'll look at how to write all of this in just a bit. Now, going back, you can copy this shellcode inside your file. You can copy this part in here entirely and then paste it at this location, which is what I've already done. And now let's understand how this skeleton program actually launches the shellcode. So let's compile this program first. Let's actually go ahead and first ensure there are no stack protectors. Ensure the stack is executable. And then after that, let's compile this piece of shellcode. Now let's run this. And as expected, the shell is launched, right? Bin sh, and the shellcode length is printed as 27 bytes. Now let's actually use GDB to look into this further, to look at how that functionality in the program really works. So we'll again set disassembly to Intel. In this case, break main, which is going to be the starting point of the C program. Run it. We hit the breakpoint in main. Let's lay out the assembly. And we do not need the registers in this case. Now, if we go ahead and compare it with the program, first, of course, you have the whole printf, and then finally, we go ahead and launch the shellcode. So if you kind of scroll down, looks like we continued the program. Just a second. And GDB crashed as well. So let's just use GDB without the TUI mode. I'm probably going to spend time later to figure out what the bug in GDB was. It's interesting to see GDB of all kind of quit on us like this. Okay, let's just hit disassemble main, and here we go. Now there are a bunch of things in here which I'll leave to you. Really, the call to printf is basically after the string length is deduced. So you can go in here. Here is the call to printf. And then finally, after that, in the very end, we have a call rdx. This is what is calling our shellcode eventually. And let's verify this. Let's set up a breakpoint in here. Add this specific location. Let's continue. We've hit the breakpoint. And at this point, let's go ahead and dump rdx, say 10x. And let's basically give it rdx. And we could actually dump everything more as bytes so that we can compare it with our shellcode. Now, if you look at it, we have 31C048BB, blah, blah, blah. This is what rdx points to right now, which is really the shellcode, right? 31C048BB, etc. And we can verify this even with our C file, which we have in here. And we are about to call rdx, or rather transfer control to this location. And we could go ahead and set a breakpoint in here. And if we continue, you clearly notice that this breakpoint is hit. And now, if we go ahead and disassemble at this location, then our shellcode is now getting disassembled. A bunch of things happening in here, which we will talk about later. But really, this is how this skeleton program goes ahead and passes control to our shellcode, which then goes and executes. Right? Now, from a C perspective, really what we are trying to do is, go ahead and convert this address into a function pointer, and then we pretty much end up calling that function, right? In case you're interested from a C perspective how this works, right? So try this out. It's important that you locate the call rdx and understand why this skeleton code eventually will execute our shellcode. Now in the next video, we will look at how to write our very first shellcode in 64-bit. So thank you very much. And if you're enjoying your time here at Pentester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thank you.